Welcome everyone. So our today's topic is escape velocity, again from the lesson gravitation, class 10 physics. Alright. So here escape velocity is there. That means for the gravitation two objects should be there. Okay, and one of the object will be escape from something. Okay, so let's see what is the escape velocity. Alright, so here the definition of escape velocity is the escape velocity is the minimum velocity. Alright, it is a minimum velocity required by a body to be projected to overcome the gravitational pull of the earth. That means it is the minimum velocity required by an object to escape the gravitational field, that is escape the land without ever falling back. Okay, that means this is a velocity which a object or body must have to be free or escape from the earth's gravitational attraction, and that object will never come back to the earth. Okay, so this is the escape velocity. And you can observe the alongside picture that a rocket, when rocket is launched from the earth, what happened? It will be escape. The velocity is given, and that by this velocity only the rocket never come back to the earth. Okay, so and the rocket will be free from the gravitational pull. That means the gravitational force will not be there. All right, we have seen in vacuum there is no gravitational force, so the gravitational pull will be zero there. All right, so this is called as an escape velocity. Just to free object will be free from the earth's gravitational pull. This is called as an escape velocity. Alright, so we have seen that when a ball is thrown upwards, what happens? Its velocity decreases, and because of the gravitation of the earth, and the velocity becomes zero after reaching a certain height, and after that the stone, it starts falling down. Its maximum height depend on its initial velocity. Alright, that means the ball will go to the maximum height if higher the velocity will be provided higher to the object, so it will reach to the maximum height, and after reaching certain height its velocity will be zero, and after reaching at zero velocity it will start coming towards the earth. So according to the Newton's third equation of motion, the Newton's third equation of motion is v square is equals to u square plus 2as. So here v will be its final velocity. Now what will be the final velocity? The velocity at which it reaches the maximum height, and we have seen that this velocity is 0. Okay, 0, and a will be here minus g. That means acceleration will be minus g. Now here why this is minus g? Because we have seen in our gravitational potential energy video that for a smaller distance, that means for smaller heights, the potential energy is less than 0, and if it is less than 0, so it will be minus in negative value, so it will be minus g. Okay, so here just put out the value of v is equals to 0 and a will be minus g. So our new equation will become 0. On place of v square we will write 0, so 0 square will be 0. Okay, so 0 is equals to u square plus 2. Now on the place of a, acceleration, we will write here minus g, and s will be displacement will be same. So our equation become u square plus 2 minus 2gs. Okay, so maximum height of the ball will be s. Okay, s is equals to, this is the same equation, just we have to rearrange some terms. So s, that is displacement, will be equal to minus, okay, minus u square upon 2g. Just we have rearranged some of the terms. All right, so here thus the higher the initial velocity will be u. Okay, so if the initial velocity will be higher, the larger is the height reached by the ball. All right, that means if the maximum velocity will be provided, initial velocity will be maximum, so the height of the object will be larger, or the distance will be larger from the earth. Okay, so the ball will opposes so thus the higher the initial velocity u, the larger is the height reached by the ball, and the reason for this is that the higher the initial velocity, the ball will oppose the gravity of the earth more, and larger will be the height to which it can reach. So for the escape velocity, the initial velocity should be maximum or higher. All right. So if it is higher, then only it will oppose the gravitational force of the earth. All right, now here we have seen that the value of g keeps decreasing decreasing as we go higher above the surface of the earth, and thus the force pulling the ball downward decreases as the ball goes up. That means if the ball will reach to the maximum heights, and then what happened, the gravitational pull just to to attract the ball towards the earth, it will be decreases. Okay, and if we keep increasing the initial velocity of the ball, it will reach larger and larger heights, and above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth and can escape the earth forever and will now not fall back on the earth, and this is only our escape velocity. So this velocity is called as the escape velocity. That means if we will provide the initial velocity larger and larger, then what happened, the object will not able to come towards the earth, and their gravitational force will not be acted on that object. So this is called as a escape velocity. That means when the initial velocity will be larger, so ball will never come back to the object, will never come back towards the earth. Why? Because the gravitational pull will decreases, and this velocity is nothing but the escape velocity. Okay, so we can determine the value of escape velocity by using the law of conservation of energy as follows. Now what is the law of conservation of energy? Here according to the law of conservation of energy can neither be created nor destroyed, but can be transformed from one form to another form. Like potential energy or kinetic energy will be converted into one form to another form, but it is neither created nor destroyed. Now let's see. Here, an object going vertically upward from the surface of the earth having an initial velocity equal to the escape velocity, and it escapes the gravitational force of the earth, and the force of gravity being inversely proportional to the square of the distance becomes zero only at infinite distance from the earth. That means if the distance will be infinite, so their gravity value will be 0. Okay, and this means that the this means that for the object to be free from the gravity of the earth, it has to reach at infinite distance from the earth. That is, the object will come to at rest and it infinite distance, and it will stay there only, it will never come back towards the earth. Okay, now let's derive an equation for the escape velocity. So on the surface of there are two conditions. First is on the surface of the earth, and next is for the at infinite distance from the earth. Now let's see first on the surface of the earth. So on the surface of the earth, kinetic energy will be half mv square. Now here v is the escape velocity, that's why here escape velocity square. Now potential energy, it will be minus gmm upon r. Okay, and here total energy. Now here potential energy is why minus, because at lesser heights or lesser distance, it will be g value will be lesser than 0, and that's why it is negative. Okay, so the total energy will be E1 equals to total energy will be kinetic energy plus potential energy. Okay, so now let's substitute the value of these two. So our E1 will be kinetic energy is half mv escape square minus potential energy is gmm upon r. Alright, now let's see the velocity at infinite distance from the earth. Not velocity, it is a total energy at infinite distance from the earth. Okay, so at infinite distance, that means when the distance is very larger, the kinetic energy will be 0. Okay, now here B is potential energy. So potential energy will be minus gmm upon infinity. Now infinity, that means the distance is very infinite. So here this is a symbol for infinity. Okay, so the total energy will be E2. Here at infinite distance we have considered E2 as total energy, and it will be kinetic plus potential energy. so E2 will be 0, half 0, because kinetic energy is 0 and minus potential energy is always also 0 at infinite distance it is, so E2 will be 0. Okay, and this is infinite, so this E2 will be 0. So our E1 is half mv square minus gmm upon r, and E2 is 0. Now here, according to the law of conservation of energy, E1 is equals to E2. Alright, so value of E1 is half mv escape square minus gmm upon r. So E2 is 0. Okay, so just put minus gmm upon r will go to the right hand side, so it will become positive, and this m and m will get cancelled because these are the same. So our remaining equation will be v half v square. Okay, so just we will send half to right hand side, so half will become v escape square is equals to 2 gm upon r, just half will go to gm, so it becomes 2. All right, now our equation become, here v escape square is there na, so we will take the square root. So after taking the square root, it will be v escape is equals to square root of 2 gm upon r, and our final equation will become v escape is equals to square root of 2 gr, and this will be after putting the value of acceleration due to gravity and distance of the radius of the earth, we will get 2 multiplied by 9.8 and multiply by 6.4 and 10 raised to 6. Now 6.4 into 10 raised to 6 is the radius of the earth, and 9.8 is the value of acceleration due to gravity. So after solving this square root, we will get the final value of escape velocity as 11.2 km per second. Okay, now here student, this half this come that after getting square root of 2 gm upon r, we are writing here square root of 2 gr, so half this has come. Let's see. Okay, so we know that acceleration due to gravity is z is small g is equals to gm upon r square. All right, so here we escape, we will write here, we will put the value of g in the this. Okay, so what we will get, square root of 2 gm, so the equation before is square root of 2 gr, that is 2 gm upon r, so we will here multiply and divide that term with r. Okay, so it will become 2 gm multiplied by r upon r into r. So this value, that is gm upon r, this is nothing but the acceleration due to gravity, gm upon r square. So instead of gm upon r square, we will write here 2g and remaining r. So I hope you all have understood this little explanation. All right, so the spacecraft which are sent to the moon or other planets have to there is initial velocity larger than the escape velocity, so that they can overcome Earth's gravitational attraction and can travel to these objects. So student, I hope you all have understood the escape velocity. This is the last topic from the lesson gravitation, and here we have completed our total chapter, and the numerical part we will do in our another video. So I hope you all have understood this simple explanation. Thank you all of you.